Hello again. Welcome to my class on forensic entomology. In this class, we take a look at what forensic entomology is, with its real-life application to solve crimes and legal cases. I will also define some core terms related to forensic entomology, and then look at a case study. So let's begin. Forensic entomology is the specialized field of science that applies the study of insects and other arthropods to legal investigations. By analyzing the types of insects present on or near human remains, their developmental stages, and ecological succession, forensic entomologists can estimate the minimum time since death and uncover crucial details about the circumstances of a crime. The most vital function of a forensic entomologist is determining the post-mortem interval, specifically the time elapsed between death and the discovery of a body. Shortly after death, a body begins to undergo chemical changes and release odors that attract a variety of scavenging insects. The most notable of these first responders are blowflies and flesh flies. Drawn to natural body openings, they lay eggs almost immediately. Understanding the precise timeline of an insect's life cycle is the cornerstone of this process, analyzing developmental stages and weather data. Beyond timing, entomological evidence can reconstruct the history of a crime scene, revealing if a body was moved or if drugs were present. To pursue a career in this unique discipline, explore resources like Simon Fraser University or the National Library of Medicine. Now let's look at key terminology used in forensic entomology. First, we look at the post-mortem interval, or PMI. This is the estimated time that has elapsed since a person died. Then comes insect succession, which describes the predictable, sequential pattern of different insects arriving at the scene. Oviposition is the act of depositing or laying eggs by these adult insects on or near the source. We track development through instars, which are the distinct stages of an insect larva between each molt. Next is the active feeding larva, followed by the pupa, a non-feeding transitional stage where it transforms into an adult. We calculate growth using the accumulated degree hour, measuring the thermal energy necessary for insect development. Through magnifying lenses, we look at spiracles, the respiratory organs used to identify which instar stage the maggot is in. Diptera refers to the true flies who arrive first, while Coleoptera includes predatory beetles that feed on them. These creatures are necrophagous, a term meaning dead flesh-eating, describing organisms that consume decaying tissue. Finally, the maggot mass effect occurs when a large congregation of feeding larvae generates significant metabolic heat together. Here is a case study that illustrates this incredible science. Forensic entomology plays a critical role in Japanese homicide investigations by estimating the minimum post-mortem interval through the analysis of necrophagous insect activity. In regions like Tokyo and Osaka, environmental factors such as high urban density, enclosed indoor spaces, and distinct seasonal climates drastically affect blowfly and flesh fly colonization. The case: indoor discovery in an urban apartment. An elderly male was discovered deceased in his locked mid-rise apartment in Tokyo during the early summer. Neighbors had not seen the victim for approximately 2 weeks and requested a wellness check due to a foul odor. The initial physical examination of the body revealed advanced putrefaction and mummification. Because the apartment was air-conditioned, the ambient indoor temperature was significantly cooler than the summer heat outside. This created a complicated timeline, prompting investigators to rely heavily on insect evidence to determine the exact time of death. Entomological analysis. Forensic entomologists were brought in to collect larval and pupal specimens from the victim's clothing and the immediate vicinity of the corpse. The primary species recovered were identified as the forensically significant Lucilia sericata, common green bottle fly, and Sarcophaga peregrina, flesh fly. Specimen collection. Researchers gathered a large mass of third instar larvae, the final stage of maggot growth, and empty puparia. The presence of empty puparia indicated that at least one generation of flies had already completed their life cycle and emerged as adults inside the apartment, which heavily extended the potential time window. Temperature data. Entomologists retrieved local weather logs and used temperature-sensitive developmental models. They factored in the victim's thermostat settings, calculating the accumulated degree days, the thermal energy required for an insect to develop from an egg to an adult. Calculating the PMI. By comparing the developmental stages of the recovered Lucilia sericata against the controlled indoor temperature, experts determined the oldest maggots had been feeding for 16 to 18 days. Adjusting for the time it took for the first adult flies to locate the body, the minimum post-mortem interval was established at 20 days. Case significance. The entomological findings contradicted the initial witness testimonies, which suggested the victim was alive only a week prior. The insect timeline allowed homicide detectives to eliminate certain suspects, focus on financial and personal records dating back 3 weeks, and ultimately verify a timeline of neglect and subsequent unnatural death. Japanese forensic entomology faces unique modern challenges, including the widespread use of insecticides and airtight housing, both of which can alter typical insect colonization patterns. Cases like this one highlight the necessity of localized, indoor climate modeling in forensic science. Because Japan experiences distinct seasonal shifts and diverse environments, ranging from urban centers to forested prefectures, university researchers, such as those at the Chiba University Graduate School of Medicine, map regional carrion fly populations. In medico-legal autopsies, forensic investigators recover adult flies and larvae from human remains and rear them to identify the exact species. Key developments shaping the discipline in Japan today include species profiling. Entomologists use local blowfly and fleshfly records to match the developmental stages of maggots with local weather data. This helps calculate how long a body has been exposed to the elements. For molecular identification, researchers increasingly turn to DNA analysis and molecular taxonomy on insect samples. This allows investigators to identify species even from degraded specimens, or to detect human DNA within the insect's gut contents. While traditional entomology is an evolving tool in Japanese police investigations, scientists advocate for greater integration with legal medicine, molecular biology, and computing. I hope you enjoyed this video. I have more forensic learning material to show you soon. Please like, subscribe, and drop a comment. Thank you.